A Kalman filter is a smart way for a computer to estimate something accurately, even when the measurements are noisy, incomplete, or unreliable. Think of it as a machine that constantly guesses, checks, corrects, and re-guesses what's really happening. It's basically an algorithm that says, here's what I think is happening. Here's what I just measured. Let me combine both to get a better, more accurate estimate. Then repeat steps 1 through 3 forever. It's used in self-driving cars, GPS, drones, finance, robotics, navigation, and trackers. Because the real world is messy, but the Kalman filter gives a clean, stable estimate. The core idea: a Kalman filter blends two pieces of information: your prediction, what you expect to happen based on previous information, and your measurement, what your sensors are telling you right now. Neither one is perfect. Predictions drift over time, and sensors are noisy or inaccurate. The magic is that the Kalman filter weights each side intelligently. If the sensor is noisy, trust prediction more. If prediction is uncertain, trust measurement more. It's like a smart balance scale. A real-life analogy: driving in heavy fog. You're driving through fog and can barely see the road. Every second you do two things: predict, you think, if I keep this speed and direction, I should be here in 1 second. That's your internal expectation. Measure, you look out the window. I think I see the edge of the lane here. But that measurement is noisy. Fog makes it unreliable. Combine, you merge your prediction with what you faintly see. If your eyes see something clearly, you trust them more. If visibility is awful, you rely more on prediction. This fusion gives you the best guess of where you actually are. The Kalman filter does exactly this, dozens of times per second. Another example: GPS on your phone. GPS jumps around due to tall buildings, clouds, or bad signal. One moment your location says you're on the road. The next moment it says you're standing inside a lake. Your phone uses a Kalman filter to smooth this out. It says, GPS says you moved 30 meters. But your speed sensors say you didn't move that far. Let's combine them and pick the most reasonable location. This is why your blue dot on Google Maps doesn't jump all over the place. Why it's so powerful: because it can estimate hidden truth even when inputs are messy. The Kalman filter gives smoother movement tracking, more stable estimates, more accurate predictions, and less noise and jitter. It's like having a superhuman sense of intuition. How it actually works: each round, the Kalman filter does 2 big steps: prediction step and correction step. The prediction step: the filter uses previous state, velocity, motion, and known physics to predict the next state. It basically says, based on how things were going, this is where things should be now. Then the correction step: it checks what sensors just measured, how reliable those sensors are, and the difference between prediction and measurement. It corrects the prediction based on real-world data. This cycle repeats constantly. The secret ingredient: trust weights. The Kalman filter is constantly calculating: how much should I trust my prediction versus my measurement? If the sensor is very noisy, like foggy vision, trust prediction more and adjust only a little. If prediction is uncertain, like moving on ice, trust measurement more and correct heavily. This dynamic trust adjustment is what makes the Kalman filter special. Why it's used everywhere: because real data is almost always messy. Kalman filters are perfect for tracking a moving object, estimating a hidden variable, removing noise, smoothing signals, predicting the next state, and handling uncertainty. Self-driving cars use dozens of them simultaneously. Robots rely on them for stable movement. Finance uses them to filter noisy price data. GPS uses them to reduce jitter. They're everywhere because they're elegant, stable, and extremely reliable. In the simplest possible words, a Kalman filter is a smart estimator that mixes prediction and noisy measurements to produce the best possible guess of what's really happening. It predicts, it observes, it corrects, it repeats, and it does it beautifully and efficiently,